So, you need some help and information on diagnosing the diesel fuel and electrical systems, huh? Well, I guess I can give you some help on them. Now, some of you may wonder who I am. I'm Rudolph Diesel, and I'm sure you remember me from the Basic Diesel Principles video program. Well, I've come back again. Really, diagnosing these systems is not that difficult if you use the right approach. Now, I've been around diesel since they first came out. In fact, I invented them. I'll tell you, over the years, I found that the basic common sense diagnostic routines have stayed the same. Now, there's lots to cover on the diesel engine, so I'm going to have my young friend Rick to assist me in some of the explanations. Now, Rick, as a Ford diesel technician, what do you feel is the most important bit of advice you can give to your fellow technicians before they go to work on the diesel fuel or electrical systems?
Well, Mr. Diesel, I've found when working on these modern diesel-powered vehicles that it's important to always use the shop manual because of the differences between models. You'll find that the shop manual will be a tremendous help, so make sure you use it.
Let's start out with fuel system diagnosis. The first thing to do is become familiar with the special tools that are used in this area. Now, let me tell you, the tools used in diagnosing the fuel system are a lot different on these diesels than with the gasoline engines. Let's take a look at the special tools used in diagnosis so you can begin to familiarize yourself with them.
This is the gauge bar, and it's part of the Rotunda pressure test kit. It consists of 4 different pressure gauges and a magnehelic gauge. It hooks into several different places on the fuel system, air induction system, and engine, where important pressure checks have to be made.
Over here, we have some of the other tools that are used in fuel system diagnosis. This is the dynamic timing meter. It is used to check the fuel injection pump timing while the engine is running. Here we have the cetane tester, which is used in determining the cetane rating of the fuel. In addition to these tools, you should know how to properly use the injection nozzle cleaning kit, injector nozzle tester, the photoelectric tachometer, and the diesel compression tester. Notice that the scale goes quite high on the diesel compression tester. This is because of the high pressures produced by diesel engines. Don't try to hook up your regular compression tester to the diesel engine. The higher pressure produced by the diesel could break the conventional compression tester. Rick?
Next, we have the throttle controller, which is used on the engine during certain tests which require the engine speed to be held at certain specified RPMs. Use of this tool, or others designed to do the same thing, help to assure accurate test measurements. Last, I want to show you the static timing tool. It's used to set fuel injection pump timing with the engine off. This tool is used in conjunction with a dial indicator to measure the amount of plunger lift in the fuel injection pump when the engine is at number 1 top dead center.
Not all of these tools that we have gone over here will be used on the different diesel engines that you'll be working on. Some will be used on all of the engines, others may be used on only 1 or 2 different engines. The main thing, though, is for you to be familiar with them and know they exist. You'll find that the way a tool is used or the way it is hooked up will vary between engines. To find out exactly how a tool is to be used or how it is to be hooked up, you should use the proper service publication. These books will give instructions on exactly how specific tools should be used and how they should be hooked up. Also, some of the tools or the adapter kits that go with them for specific engine hookups will include instructions. Now that you've got an idea of the tools that we're going to use, let's get into diagnosing diesel engines. Obviously, a customer is not going to bring his car in for the fun of it. There's got to be a reason. Here's a list of reasons why a customer may bring a diesel vehicle in for service. The most logical cause of all of these problems is in the fuel system. As you can see by these charts, there are many symptoms that can be blamed on malfunction in the fuel system. To determine if the malfunction is in the fuel system and what is causing it, it is important for you to have a working knowledge of the fuel system used by diesel engines. Essentially, the fuel system has 2 sides to it. The low pressure side, where fuel pressure should seldom rise above 10 psi, and the high pressure side, where fuel pressure can reach pressures of over 2,500 psi. Let's take a look at the components that make up the fuel system and what they do. We start with the low pressure side of the system with the components inside the fuel tank. Rick?
This is the fuel sending unit from a diesel-powered car. It looks similar to that used in a gasoline-powered vehicle, except for the addition of a fuel return line and the fuel pickup. Most Ford diesel-powered cars and light trucks will use this pickup because it's designed to assist in removing water from the fuel tank. Make sure that whenever the sending unit is removed and replaced in a fuel tank, that the pickup is in place. Otherwise, water could build up in the tank and cause a lot of problems. This is a sample of the fuel line used on a diesel-powered vehicle. Let's take a closer look and compare this line to the line that is normally used on a gasoline engine. Notice that the fuel line of the diesel has a larger inside diameter than the gasoline fuel line. This is because diesel fuel is normally thicker than gasoline, especially in cold weather. Along the way to the engine, the fuel must be filtered, have any water that might be in it removed, and if it's cold outside, be heated to prevent clogging of the filtering line. This is accomplished, in many cases, by a fuel conditioner, which contains all of the components just mentioned, plus a few other things, like a warning system to inform the operator when the water-fuel separator should be empty, a device for emptying the water, and in some cases, a priming pump for assisting in the removal of air from the fuel system. Now, some fuel systems make use of these components separately. It's not uncommon to find the fuel heater, fuel filter, and water-fuel separator as separate components in a fuel system. To pump fuel from the fuel tank to the low-pressure side of the fuel injection pump, a fuel pump must be used. On diesel engines, this is commonly referred to as the lift pump. It can be similar to an automotive-type fuel pump, or it may in some cases be an electric pump. Sometimes there is no lift pump in a diesel fuel system. In cases like this, the fuel is pumped by the transfer pump located inside the fuel injection pump. All automotive fuel injection pumps contain a transfer pump, which is also responsible for maintaining fuel pressure within the pump for proper cooling and lubrication.
Thank you, Rick. That takes us through the low-pressure side of the fuel system. Now, let's take a look at the high-pressure side of the fuel system. The components that make up the high-pressure side of the fuel system are the fuel injection pump, high-pressure fuel injection lines, and the fuel injectors. The fuel injection pump is responsible for pressurizing the fuel to over 2,500 psi and delivering it to each individual cylinder at precisely the right moment. Service on the pump is not allowed in most cases because of the precise components inside the pump, and the fact that the pump is the last thing that should be suspected of malfunctioning. They just don't break very often. There are a few serviceable components on the pump, though, like the electric fuel shutoff solenoid and some of the seals. Check the shop manual, though, to determine what can and can't be serviced. The fuel injection lines are responsible for delivering the high-pressure shot of fuel to the injectors. Notice here that the length of the fuel injection lines are all the same. This is to ensure that it takes the same amount of time for the fuel to reach each individual cylinder. The fuel injector is responsible for atomizing the fuel going into the cylinders. They don't normally open until the fuel reaches injection pressure. The fuel injector first has a small initial injection, which starts to burn immediately upon entering into the pre-combustion chamber. The initial injection is followed immediately by the main injection, which allows combustion to be started. As you can see, the placement of the fuel injector and the shape of the pre-combustion chamber cause the fuel and air to swirl and mix together. This assures that the fuel will burn completely once the mixture reaches the main part of the combustion chamber. Use of this design cuts down on combustion noise and emissions. Anything that causes the injector not to spray fuel in the manner shown is going to cause problems, most probably noise like excessive knock and maybe excessive smoke. Now that you've seen the fuel go all the way from the fuel tank into the combustion chamber, you probably think that you've seen the whole fuel system. Well, there's more. Actually, only about 10 to 20% of the fuel that is pumped into the fuel injection pump and injectors is used in the combustion chamber. This excess fuel is returned to the fuel tank via the fuel return line. You'll find that there is a fuel return line coming off the fuel injection pump and the fuel injectors. Clear, unrestricted flow of fuel through the fuel return line is essential to the proper operation of the diesel fuel system.
Now, the information that we've just presented should give you a good base to work from in learning about the diagnosis of diesel fuel systems.
Let's take a moment for a quick check to make sure that you're up to speed on what we've been going over. the fuel system can be diagnosed on any diesel engine.
and how the gauge bar is used as a diagnostic tool.
We'll use this 4-cylinder diesel for most of the demonstration, and other engines as necessary.
And I'll generally follow the diagnostic sequence in the shop manual, which is designed for this particular engine. Every engine is somewhat different, so be sure you use the proper service publication for the specific gauge hookups and the order of testing that relates to the condition. Speaking of conditions, the fuel system checkout is related to engine performance conditions: poor idle, poor economy, stalling, black smoke, and so on. If the problem is hard starting, you should always perform an electrical checkout first. Always begin by a visual check around the engine, and especially the fuel system components, for any signs of external leakage. A diesel fuel leak can be the cause of performance problems. Also look for any bends or kinks other than normal in the fuel lines that could restrict the fuel flow and cause the engine to run poorly. Remember, if you do run across a damaged line, be sure it is replaced with one that is specifically for that engine and model, especially on fuel injection lines.
Likewise, take a hard look at the exhaust system, since any exhaust restriction will prevent proper engine breathing. Look for kinks and dents.
To get back to the fuel system then, you always concentrate on the low pressure part first, because the injection pump doesn't often give trouble if it's getting a good supply of fuel. What you're looking for first are flow restrictions, air in the system, or lift pump trouble. One of the most important tests then is pressure at the fuel filter outlet, which can tell you if there's a restriction in the fuel flow in the low pressure side of the system. For the test on this particular vehicle, a combination vacuum pressure gauge is attached to the fuel filter outlet. This is the number 2 gauge on the rotunda gauge bar. Notice the fuel filter on this engine is downstream from the transfer pump, so it will be exposed to a negative or suction type of pressure. Also, there is no lift pump on this system. The transfer pump must take care of drawing fuel from the fuel tank and maintaining adequate pressure within the fuel injection pump. Run the engine at specific RPM and see if the pressure is what is called for. If so, the test is over. If not, if the pressure is too high, the filter may be plugged, or there may be a restriction before the filter. If the pressure is too low, then this is an indication that there may be a pump problem, or it could point out an air leak in a fuel line or connection. If the pressure was excessive, you would check the inlet pressure of the fuel filter or conditioner, and the difference between the two readings is pressure drop, which tells you if the restriction was in the filter or somewhere in the system before the filter. If the pressure was low at the filter inlet, this would indicate that the filter was clogged. If the reading at the inlet was still excessive, then this would indicate that the restriction was prior to the filter in the tank or lines. If the transfer pump was suspected as the problem, you would first want to check for air in the fuel and then move on to the transfer pump check. But on a system equipped with a lift pump, the lift pump would have to be checked.
There are 3 tests for most lift pumps: a check of inlet vacuum to see if the inlet is restricted, a pressure out test, and in some cases a capacity test to measure output volume. For the inlet test, we use the vacuum gauge, which is the left side of gauge 2 of this gauge bar. And for the pressure output test, the right side of the same gauge is used. These measurements must be within specifications. In addition to checking inlet and outlet pressures, sometimes fuel is run into a graduated container over a specified time period to see if the pump volume is up to specifications. Well, you get the idea how to make pressure tests at various points, and the results will pinpoint restrictions for you. Just follow the shop manual sequence and make the test it calls for until you find the restrictions. The shop manual explains all of these tests in more detail. Use it. Another important check of the low pressure system is for air. Air gets into the system very easily if there is a leak in the suction side of the lift pump, and it causes all sorts of performance problems. To find an air leak, install a clear plastic line temporarily and run the engine long enough for bubbles to clear. If they persist, there is a leak. In some cases, engines will be equipped with clear plastic fuel lines from the factory to help determine if there are bubbles in the fuel. To locate the leak, connect the pressure pump on the gauge bar to the fuel line leading to the lift pump inlet. Pump it up to about 15 psi, and if it doesn't hold pressure, brush some soapy water onto all of the connections until you find the leak. Now you may at times have to check the fuel quality to see if it's dirty and if it has the right cetane number. For that, collect a sample of the fuel from the vehicle being tested, preferably also smell to see if it has gasoline in it. If it's contaminated, you'll have to purge the fuel system using the approved procedure. The cetane rating must be at least 40 for Ford diesel engines, and you check it with the cetane tester, which works like a hydrometer. If it checks below 40, the fuel is going to be hard to ignite, and you should advise the customer to fuel up somewhere else. Well, that was a quick look at how to diagnose the low-pressure fuel system. Before we discuss the high-pressure side, there are two important diagnostic tests you can make with the Magnehelic gauge on the gauge bar. Rick?
Right, Mr. Diesel. First, there is the possibility of air cleaner restriction. If the engine doesn't get enough air, it causes poor performance, fuel guzzling, and usually black smoke. To test it, the gauge will measure pressure drop across the filter by reading the very slight vacuum on the airbox side when the engine is running. On the vehicle, the vacuum side of the Magnehelic gauge is connected to the port on the air cleaner. Run the engine at specified RPM to get a good volume of airflow, and the gauge reading is the pressure drop. If it's above specifications, install a new air filter and check it again. Don't blow the old filter out with air and put it back in. The crankcase pressure test tells you if there's too much cylinder blow-by due to piston ring or cylinder wear. For this test, use the right side of the Magnehelic gauge connected to the crankcase vent tap. Make sure the dipstick opening is plugged and run the engine at specified RPM and read the gauge. If it reads above specifications, make a compression test to diagnose the engine mechanical problem. Now, in the high-pressure fuel system, there are many conditions like missing, knock, and lost power that can be caused by damage in the high-pressure fuel lines or by problems with the fuel injection nozzles. To isolate a nozzle problem, run the engine and momentarily loosen the pressure line at the nozzle. If there's no change in performance, that nozzle has a problem. Remove it for bench testing and inspection. Test the nozzle by attaching it to the tester and pumping tester spray through it, as I'll describe. Make sure that only the correct test fluid is used in the injection nozzle tester. Diesel fuel should never be used in testing because of differences in the viscosity of different diesel fuels. These variances could cause incorrect readings. Be very careful to avoid being hit by the liquid being injected. It is under extremely high pressure, more than enough to pierce the skin. Should diesel fuel or test fluid pierce the skin, it will cause blood poisoning and must be taken care of by a doctor immediately. First, pump the handle slowly to check the opening pressure. This is the highest reading on the gauge as you cause the nozzle to spray. Check it against specifications, then check the valve seat seal by holding a pressure just under the opening pressure. If the tip stays dry for 5 seconds, the seal is good. If it drips, replace the nozzle. Finally, check the spray pattern by pumping the tester rapidly. You should get a fine, even mist, and it should not be too wide. If the pattern is off-center or not uniform, or if the fuel spray doesn't cut off cleanly after each stroke, replace the nozzle. Nozzle testing takes a little time, so be sure you have performed all the other tests and checks first before you decide to remove an entire set of nozzles for bench testing. But, and this is important, also be sure you have checked out every item on the performance sequence, including accelerator linkage, curb idle, and injection pump timing before you replace the high-pressure injection pump.
Also, be sure to follow the recommended checkout sequence in the shop manual and to read the shop manual for more information on diagnosis of the fuel system.
Now it's time for a quiz. Hi, we're back again, this time to talk about diagnosing the principal electrical systems on the diesel engine for starting or cold start performance problems. The systems we'll be looking at are the starting and glow plug control systems. The starting system, battery, cables, starter relay, and starter motor are of course the first place to look when there are problems of no cranking or cranking too slow, just as they are in a gasoline engine. Glow plugs and their wiring harness and control system may have to be diagnosed when the problem is no starting, even though the engine cranks, hard starting cold, or missing cold.
Simple enough. And the diagnosis of both systems is very easy if you understand simple electrical diagnosis and follow the manual. Let's look at the diesel starting system first. you'll find that the diesel will use a very large high-capacity battery. In fact, some vehicles will even use two batteries because we need a high ampere capacity to crank a high compression engine. The starter motor is the solenoid-operated heavy-duty design. The solenoid on the starter closes the starter motor power circuit when its S terminal is hot. The starter relay is used simply to close the start circuit to the solenoid when the ignition switch is in the start position. Glow plug solenoids may look similar to starter solenoids. Don't get the two mixed up, especially when attempting to start the vehicle. Since there is battery voltage running through the starter relay to the starter at all times, it is important to disconnect the battery ground to disable the electrical system. Never try to disconnect the battery from the system at the starter relay. Grounding the wrench while loosening the nut could cause severe damage to the electrical system and possibly personal injury. The starting system tests are in your shop manual and are explained there. Let's go on now and look at the glow plug diagnosis, which also is very simple when you understand it. Remember that each cylinder has a glow plug to heat it before the engine starts cold. And the plugs are self-grounded and get their power from various kinds of control modules. You will find that glow plug systems are all similar in function, but each is different in operation. Check the shop manual or other service publications for specific operational information. Essentially, the glow plug systems operate in this manner. The control module applies a full voltage to the plug for a few seconds, then a reduced or pulse voltage, depending on the system, for afterglow when the engine starts. Most glow plug systems operate off the time engine temperature principle. The control unit will shut off the voltage if the coolant is warm or after a certain period of time in most cars. The control module receives input from several sources to determine the length of glow plug operating time. For diagnosis, you need to know how to think a little and to make simple tests for power in, module ground, and signals to the control. The most important thing, though, is to use the shop manual. Now, it isn't uncommon for a single glow plug to burn out, and if it does, that cylinder can misfire cold. If the problem is cold miss, you can diagnose it very quickly by checking glow plug continuity on the engine. Rick?
Connect an ohmmeter between the power terminal of the glow plug and ground. Note that some glow plug systems require that the power wire be disconnected from the glow plugs before making this check. Others do not. During this check, the ohmmeter should show continuity. If the ohmmeter shows an open circuit, the glow plug should be replaced. There's usually no in between. A glow plug is either good or bad. It will show continuity or it won't. If the glow plugs are okay, the glow plug system will have to be checked out further and in more detail. For more detailed checking of the glow plug system, the type needed to diagnose problems like no starting, hard starting, or poor cold performance, or cold missing when the glow plugs test good, it's best to go to the recommended test sequence in the shop manual for the best results.
As this simplified diagram shows, there are many different components that have to function together for the system to work properly. Components, component location, and service techniques will vary between the different glow plug systems. So, be prepared to use the shop manual to help in diagnosing possible problems in the module, glow plugs, wiring harness, switches, relays, lamps, and fuses. The important point is to determine where the problem is within the glow plug system, using the proper diagnostic techniques. This will assure that the malfunction is found and corrected. Essentially, you have to find out if there is power to the module, if the power is going to the glow plugs, if the power is staying on the glow plugs for a sufficient period of time, and if the components that input information to the glow plug module to determine glow plug operation are functioning properly. As I said before, the order and method for checking the glow plug system will vary between different models and engines. So make sure you use the proper shop manual or other approved service publications.
One of the important things to watch in many cases to help determine if there is a glow plug problem is to look at the same thing which the customer looks at, and that's the glow plug operation lamp. Sometimes, if there is something wrong with the system, the lamp will not work in the same way. If the customer mentions this, it can help in your diagnosis. Also, make sure that the lamp is working. It's important that the driver knows when it's okay to start the engine. Another important lamp found on the diesel vehicle instrument panel is the water and fuel warning lamp. It's activated when water in the water-fuel separator collects to the point where it goes over the tip of the probe, causing it to ground. It's important to the life of the engine that this lamp be working. A small check that can be made to assure that the warning system is working is to ground the tip of the probe. Grounding the tip of the probe should cause the warning lamp to come on inside the vehicle within 10 seconds. If the lamp does not come on, then there is something wrong with the system that will have to be repaired. Bulb operation is checked whenever the vehicle ignition switch is turned to the on position. The lamps should come on at this time. One final item before we close this part is the fuel shutoff solenoid you'll find on some diesels. When you turn the key on, the solenoid has to click and let the fuel flow. Otherwise, the engine won't start. If it doesn't click, check for 12 volts at the power terminal in the ignition run and start positions. If there's no voltage, repair the circuit. If voltage is there, replace the solenoid.
And that is how simple it is to diagnose diesel electrical systems. Reads the reference book for more information, knows the systems, and follows the easy step-by-step electrical test procedures in the shop manual. Well, that's about it for diesel fuel and electrical system diagnosis and repair.
Thanks for your attention, and please join us for the continuation of our program on side 2 of this video disc. Now it's time for you to take a quiz on the diesel electrical system.